Okay, I think that should be good. All right. I don't think anybody is here on the chats. Anybody's tuning in. If you are tuning in and you're on the chats, write something and say hi, I guess. Anyway, okay, barring that, I'm just gonna go into just messing around with some Houdini. If you're in the chats and, you know, can say hi, say hi. And if you have any questions or anything like that. Alright, but we're just gonna be messing around with Houdini, I guess. So, let's see. One of the things I was gonna do from last week was there was a question in Grayscale Gorilla's Ask GSG like 2 weeks ago or something on how to create this sort of look. This is not 3D animation or anything. This is actual. This is an actual sculpture. This is actually made in real life. Oh, hey, Quantum Negative. What's up, man? Hope you're doing good. Studying, maybe? If you have anything you want me to go over, or if you have any questions, let me know. Otherwise, I was just going to do this real quick. So this is something made by an artist named Temsil Van Essen. And it came up in Ask GSG. And it's actually the Ask GSG, if you're not familiar with that, it's Grayscale Gorilla's like Cinema 4D live stream where Chris Schmidt just answers any type of questions and tries to recreate any and almost any and everything in Cinema 4D. So this came up in one of the questions, and he actually was able to do this really, really easily in Cinema 4D, but it just looked so interesting that I wanted to see if I could sort of recreate the same look with Houdini. So it's not super hard to do. Honestly, it's more straightforward in Cinema 4D, but I think with Houdini you get a little bit more control. In Cinema 4D, it's done with, I believe, displacement maps and textures. But if it was in Houdini, I would approach it a little bit differently. But then again, who knows if the way I'd approach it is actually anything close to correct. So we're going to go into Houdini, and we're going to do our usual where we put in a geometry node, and we'll throw that guy down there. And so the great thing about this is it'll work on anything. So let's just let's make a weird looking crystal first, just for the hell of it. So let's put I don't know how to pronounce this in real. People pronounce it differently. Platonic, whatever. We'll just make a platonic solid, and we'll make a. Let's go with a dodecahedron, right? But on top of that, what I'm gonna do is I'm going to put a mountaintop, just so that I can move around those points just a little bit. So I'm not gonna move it around a whole bunch, but just a little bit, so you get a little bit of deformation like that. And then what I'm gonna do is then I'm just gonna take a tube. So I'm gonna put the tube here and take a look at it. So I'm gonna template it by hitting this pink button. You can template it so you can actually sort of see both of these in context without having them connect each other or anything. So I'm going to put end caps on it, but I'm going to make it a polygon. So it's gonna look like this. But I'm gonna bring down the columns. And I'm also going to bring in the radius. So I'm going to bring that in a little bit, and I'm bringing up the height. So it kind of at least encompasses everything like this. Maybe bring the columns down to 6. So it sort of looks something like this. And from there, what I'm going to do is I'm just going to do a booleans. And I probably brought this up before, but I love Houdini's booleans. They just work. If you've ever used booleans in Cinema 4D, they are glitchy and poppy and weird, but in Houdini, they're awesome. So I really like using them for certain things. They can still bug out sometimes if you feed it just really weird geometry or a lot of geometry. But for what we're doing today, it's great. So I'm gonna do that, and on the tube, I'm going to bring in the radius just a little bit to get more like something like this. So we get more of a crystal look. And actually, if we also put a mountain on the tube, then the vertical lines also get a little bit of a weirdness going on there. They get a little bit of a variation because of the noise from the mountain. So we can get something like this. So here's the base geometry that we're going to be working off of, okay? And so from there, what we're going to do is, if we take a look at what we were trying to model from before, this whole thing, you know, then we're just going to eat into the structure. And so the way that I would do that is, you could use anything to actually eat into the structure, but what I'm going to do is I'm going to have something grow and eat into it. So how I'm going to do that is I'm going to just grab any old point, or actually we'll have them grow on the surface. So we'll have them grow by put a scatter node on top of this, and I'll push it off to the side, and I'll show you why I push it off to the side, because we're going to be branching off more stuff here afterwards. But a scatter sop just places a whole bunch of points, and by default it's going to place about 1,000 points. We don't need that much, so let's just make it something more manageable, like 9 points. So it's just randomly putting 9 points all over the surface. So if I template this, it's just all along the surface of this. So that's where we're going to start all of our where it's going to start eat into the geometry. And so on those points, I'm going to put a copy to points sop. Copy to points. There it is. We do that. And what a copy to points does is it requires points, and whatever these points that you feed it, whatever geometry you feed it into this first input, it will copy those onto all the points that you give it here. So what I'm going to do is on that guy, I'm going to put a sphere. So I'm going to input the sphere. So what that does is it copies the spheres onto all those points, but the spheres are huge. So let me turn off that template. And so the spheres are huge. And they're also primitives. So we're going to switch those polygons. And I think what we can do is up the frequency just a bit. So maybe something like, I don't know, 12 maybe. So we got a little bit more frequency there. And let's turn down the scaling just a bit. So now we've got these spheres here. We're going to make them about that big. Like again, because this is Houdini, we can just change all this on the fly. So for now, we're just going to keep it circles. And then we can put a little bit of noise on them maybe, and we can even animate the noise and do stuff like that. So let's just keep using more mountain sops, because mountain sops will give us this sort of look, which is kind of weird, but actually, so they're not all the same. Let's do this. Let's put the mountain sop after this. So we got a little bit of this action going on here. Okay, hopefully that makes sense, because if we put the mountain on the sphere before it hits the copy to points, all the copies will have the same type of mountain look. But now it's putting a mountain on all the geometry together, so we're getting this variation. And so we're gonna just bring down, I think, the element scale a little bit, so we get a little bit more of this look. But we don't need it to be that dramatic, I think. Just a little bit of noise, and maybe, actually, you know what? Just give it I just want a little bit of variation here. So let's do something like that. And again, we can change this up later. And so from there, all we're gonna do is we still have these guys, and so basically it's on the surface of this geometry, and so we're going to eat into this geometry. And what we could do is we could just do another booleans actually, which is not what I'm going to end up doing probably, but we could do another boolean and just have this guy eat into this guy. And by default, oh whoops, by default, let me turn off the template on that and put their visibility back on this one. By default, what happens is a boolean interacts uses the intersect and the way that it combines these two. So wherever the two intersect, that's what it does. And that's what we needed to do up here earlier when we were doing the booleans to make the actual crystal. But in this instance, what we could do is make it a subtract, so you can actually subtract these guys out from here. So it's actually pretty cool. And because, like I said, Houdini booleans work pretty well, they would probably even work on the fly. Like if I started to up the scale of these, you can see it eats into it, and it's actually pretty cool. You could actually make it eat away into something. Now I wouldn't really do that by animating it. You could, and the way to animate a keyframe, to animate a volume, or sorry, animate a value, you would just hold Option or Alt on Windows and click right here. It turns green, and sorry, and it turns green. And then you could go and you get this little green tick right here. That means you put a keyframe on this frame. And you go down the timeline, and at 46 frames, we could just make it a little bit bigger. And it would actually eat into it to the point where you actually eat into it that much. You could, and you see how it turns yellow. And that just means that there was a keyframe earlier or somewhere in the timeline, and you've now changed the value, but you haven't committed it to a keyframe. So now what you can do is actually hold Option or Alt on Windows again, and just click it again, and that commits to a keyframe. So now if you go in between here, you can actually see that it's animating, which in this instance, like I said, because Houdini's booleans are so good, it animates actually pretty well. And you don't really see too much errors. Where you could start seeing problems is sorry, where you could start seeing problems is if your geometry is really complex. Now, we're not working with too complex geometry. These spheres are kind of clean. Yes, we have put a little bit of noise in here, and there's a little bit of noise in our original crystal, but we don't have bad geometry where we have holes or overlapping polygons or anything like that. So for the most part, Boolean is behaving correctly, so we could keep going with this. But if you, like I said, if you just have anything like a different different type of 3D object in here, like something that you imported or something that was kind of not created very in an optimized fashion, you could get a lot of errors, and you could just get like polygons jumping around or glitching out or popping off and on and things like that. And that's, even with Houdini's awesome Boolean functions, you can still get those kinds of errors. So if that's the case and that's what happens to you, there's a different way, or sort of a different, it's sort of almost similar to the Booleans, but it's sort of a different concept. And what we're going to do is we're going to be committing everything to VDB, turning them into SDF, sign distance fields. I think that's what they're called, but the VDBs. So we're going to actually go to VDB from polygons. So we're going to take VDB from polygons. And so I'm going to leave this off to the side to show you that this is a perfectly viable option to do it in this instance, but you could get errors. So we're going to do it with the VDB method. So I'm going to pump the mountains, the spheres, into this VDB volumes, or VDB from polygons. And then what that does is, if you take a look at it, it turns it into a volume, a VDB volume, volume database. I think that's what that stands for. Volume. Yeah, okay, and so they're based on voxels. Voxels are kind of like three-dimensional pixels. Basically, just think of them as cubes. So because the voxel size is kind of relatively high, you can actually start seeing all of these cubes. So we're going to bring that down a little bit to something a little bit more refined. And so you see the resolution kind of change a little bit better. And we're going to do the same thing with this guy. And so our crystal also turns into a V2B. And if you grab this output and you just feed it into this second output or second input here, that just means that now on this guy, you no longer have to change the input here. And what that does is it sort of makes this the controller. So if I up the res on this, it basically ups the res on this one as well. All right. So now, having done that, what I'm going to do is we can do almost sort of the similar thing with the booleans, but use a V2B combine. God, same thing always happens, guys. Okay, so now this is sort of like with SDFs, it's sort of like the same thing as Boolean. Well, now what we can do is we can actually use these FDS union, intersection, and difference. So this is similar to what the Booleans were doing, but it's doing it on a volume basis with sign distance fields. So if I do the difference here, which is sort of like a subtract, I sort of get the same thing. So now it's basically eating into it just like before, but instead of eating into the polygons, it's eating into the volumes. So once we do that, we can just go and turn this back into actual polygons. So you can take a convert B2B and convert it back into polygons. So now if we take a look, we're converting back into polygons. Now the downside to this is the higher your V2B from polygon voxel size, so the lower this number is, the more resolution you get because the smaller the voxels are, so you get a better resolution. But the downside to that is when you convert it back into V2Bs, you can see that the mesh is like pretty detailed now. So you're getting a pretty much heavy, a really heavy mesh compared to what it was before. Say for example, if we take a look at the Boolean function here, you see how there's a lot less polygons. So that's kind of like it's kind of a trade-off. That said, this one is going to be a lot more stable in terms of, you know, the geometry eating into itself and things like that. It's also, if you also have noticed, it's not exact. It's not, you don't get the sharp edges that you do when you do something like this. You don't get these sharp edges. That's the nature of doing it with V2B from polygons. You could theoretically up this resolution by turning this down even lower, but the lower you go and the more resolution you get, the more complex the geometry gets, the more slower the render is going to be, the more longer the calculation will take, and things like that. So you got to take that into account. Cool. All right, and so from there, in order to get, so, you know, if we take a look back at what our target was, so now we've got, you know, this sort of eating into the geometry look, but what we're trying to do is get this layered type of shader look. And what you can do with that is actually, the way the GSG did it was with the shader. But for us, we're going to use, we're just going to color the points, and that will transfer over into the shader. So what we're going to do is, let's see if I remember how to do this correctly. Okay, so we're going to put a color stop, but the color stop is going to be at this level. Okay, so at this level, if I take a look at it, I'm going to color it. Let's just make it so it's easier to understand. Let's just make this level black. Okay? So on this level, it's black. And actually, we should do it at, I'm trying to think of the best way to do this here, people. Yeah, actually, no, let's do that. Sorry, let me undo what I just did. So let's leave it at black as this. We might run into some problems. I'll fix it if that's the case. So On top of that, what we need to do is we need to attribute transfer. So on this guy, I'm going to put another color sop. But on this one, I'm going to color it white. So now we have black here and white here. And so what we're going to do now is we're going to take an attribute transfer. So with Houdini, everything is stored in attributes. So if you take a look, and this is why I have this spreadsheet view here. Usually the geometry spreadsheet is here by the default, but I actually also put it here so I can see both of these at the same time. If you're not aware, Houdini, everything is driven by attributes. Well, most everything is driven by attributes in Houdini. So it's really a good idea to have this dialog box open, or this window open, so you can actually see the attributes that you have. So it'll give you the point level attributes, the vertices, the primitives, and the detail attributes. And so you can switch over to all of them, whatever you need to. Points is probably the most important, but there are times when you can use primitives, and there are times when you use details, and there are times when you use vertices. So. But if you take a look at the points, right now, all of my points, and you can see all these points. So, there's 81,000 points in this geometry right here on this node. It's all in context of what you have highlighted. So if I select this one, you see how everything changed a little bit. It's because it's now the context of what the VDV from polygons are. And because the VDV from polygons are now a volume, it no longer uses points. So that's why it says 0 points, or 0.0. It's only counted as 1 point, and it's just at the 0 coordinate plane. But if I go into the color, you can see that for all of my points, I have its position, so the X, Y, and Z, and also a color, because I am putting a color sop on here, and I'm saying make the color 1, 1, 1, so I'm getting CDR1, CDG1, and CDB, so R, G, and B, all of them 1. Hope that makes sense. This is a very important concept to understand. So now we have colors as an attribute on our points. Well, we also have colors as attributes here, and we made these black. So now if I use this and say attribute transfer, use an attribute transfer on this guy, and plug this into here, it's going to error out because we don't have a second input to transfer, not in the sources. So we need a source, and that source is going to be this guy. And I think this might not work, and I'll explain why. So right off the bat, when we're here, everything was white, and now since we're transferring those attributes, it's transferring those colors onto our geometry. And the color that we're bringing it from was this guy, and since this is black, it made everything black. By default, it will do that. You can actually specify the attributes that you want, and so we have CD and we have position here, but by default, it was bringing in CD anyway. So yeah, I can actually say a CD, but it doesn't make a difference. Now the power of attribute transfer, I use this all the time, and the power in it lies in the fact that you can actually have it set based on distance. So if I bring this distance down, hopefully this sort of works, but it might not. So you can see how it's sort of changing the distance, or changing the transfer of that color, and you can actually blend it. So you can actually kind of sort of blur it, or blend it, basically. That's what it's doing. So it's changing the value between black, which is 0, 0, 0, and white, which is 1, 1, 1, and we're getting a variation in between there, which is great, right? Now, it's not actually acting correctly. If you notice, so let's just turn this blend width down so you can actually visualize a little better. You see how the color is sort of, the distance is sort of being determined by these corner points, right? And you might be wondering why it's doing that, because our color is on all the sides, and so if we're transferring it from there onto this guy, that means that the sides that are the most common with each other, or the closest to the original sides, should be turning fully black, right? But they're not. It's only these in the corners, and it's because we're doing everything on the point level. So, oops, let me just stop that. Because we're doing everything on the point level. So when I highlight this, everything looks black, but it looks black because these polygons, so these polygons are being colored black because these points are actually the ones that are black. So the way Houdini works is if this point here is black, and 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 this point here is black, this polygon inherits those values. because the points are surrounding it all have, so if I select, for example, if I select the points, so you can see what I'm selecting here, and if I select this guy, and this guy, and this guy, and this guy, and this guy, okay? You see how we actually have to have them all highlighted now? Well, because they're all black, the primitive, even though the primitive that I will now select, so if I go into primitive modes and I select that guy, that primitive, which is primitive number 9, it has no value, you know, there's nothing here. But because it's surrounded by these points that I've also highlighted, and these guys all have the value of 0, it's taking on the value of 0. So it's kind of misleading in this way, but because we're working at the point level, when we transfer everything, when we transfer those attributes here, and I'm gonna turn off this point so we can actually see everything, it's only transferring it from that point, not from the actual primitive. I hope that makes sense, okay? So the way to get around that is we can either try to transfer the attributes from the point level to the primitive level, or what might be a better way to do this is, let's see, just make it so that this color attribute, or sorry, these, I should stop. Select out. So at this level, we just have a lot more points in here instead of just these points that are on the outside. And so the way to do that is, when we do a VDB from polygons at this point, so we have this guy, and before we do this VDB combine to eat out the points like this, let's just convert it back into geometry. So if we use the convert VDB to make it back into polygons, at this point, we just have a really, really dense mesh representation of what our original geometry was, right? But it's just a lot more finer mesh. So if we take the color at that point, so so this color is not here, so let's bypass it and put it back here. And this color, instead, we put the color after this gets turned into this dense mesh of polygons, because look how many points we have now. We have an awesome number of points. So if we now color it at that point, now all of these points are all black, right? Instead of before where only the polygon was made out of these corner points, now we have points all over the place, and all of them have the value. So if I select this, all of them, if you take a look, all of them have the value of black, 0, 0, and 0 on RGB. So now we're pumping that into the attribute transfer. So if my calculations are correct, whereas before the black was just bleeding in from the corner points, if we take a look at this, the blacks should now be bleeding in from the outside, right? Make sense? So if we take a look at this again, now see how it's blending in from the, so even if we have a distance threshold of 0, because they're basically on the same points here, all of our outside is now black, and all of the inside is now, because it's a distance away from our original geometry, the geometry that is this geometry now is turning white, right? I hope that makes sense. And so now if we do a blend here, we can sort of blend it in from fully black to fully white. So we get this sort of look, which is not really what we're going for with this, because we sort of want this stepped look. And so in order to do that, that's actually pretty simple. So the way that we do that is with an attribute VOP. That could be point VOP too, but we're just going to use an attribute VOP. So we're going to use a VOP network, so a VEX network, or a VEX operator here. Okay, and so in this VEX operator, if you come from a Cinema 4D background and you sort of familiar with Espresso, VOPs are sort of similar to that, except it gives you way more control than what Espresso does. But it's basically sort of similar. It's kind of like a visual programming language, and it's actually really, really powerful. So, but for today, all we're going to do is be concentrating on CD. And so basically, this is what we get from our original, and this is what we want to change it into. And so we get the CD attribute. So this is what the CD is currently, and we can change it to a different type of color. And what we're going to do is, and this works with everything, with position, with velocity, you know, normals and force and all this other stuff. So if we just did 1-to-1, that does nothing because it's porting what our original values are to the same values. But in between there, what I want to do is I want to put a ramp parameter in there. Okay, so I'm going to put a ramp parameter in between there. So that does nothing because by default, a ramp parameter, what it does is it goes to RGB color and it ramps total black to total white, which is the exact same value. So everything in between is mapping 1-to-1 at the same time. But the power of this goes into, if we could step out of this, ping you step back out of this network. My computer is lagging. Hopefully it doesn't freeze because I'm doing too many things at one time and our live stream is going on. So let's hit you again. Oh, there we go. Okay. So now on this attribute VOP, I have this ramp. And so it's the same ramp that's in here, but it's just that I get to control it out here at this level. And so what I can do now, here is actually, instead of having it be linear, let's make it constant. So if you make it constant, you see how everything turned black? It's because now this white point is here. Well, if I bring this out, you can sort of see now how that changes things. So we can actually do this and just stair step it. So actually, just to make this a little bit easier, we can just do this, put another point here, put another point here, get another black, put that here, and put another white. And, you know, just keep doing this type of thing to sort of get the look that we're going for. And so this is, I think this is really straightforward kind of stuff. So I think it's a little bit easier probably to understand. We get this little look here. And so we sort of get, and let's end it off with white. I want to have white on the inside, so let's end it off with the white. And you know, the distance between here, you can actually change it by this, or you could also change it by this attribute transfer here. So instead of having to blend with that, go that far in, we could just make it so that it's only affecting that much on the outside. And then from there, as long as whatever, so let's step back out. So let's end this and just put a null here because it's best practice for when we're done with something, we'll just have this and set it as the out. Okay, we step out here. At this level, if we're gonna make a material for it, whatever material we make, so let's just make it doesn't really matter what we make with it. Let's just make a code. I'm just gonna use a preset. So let's just use coated metal. So let's just bring coated metal. All right, we don't need two of these. That's fine. So we bring coated metal into our material palette. So if you go into materials, we're gonna have coated metal. Let's just take this and make it white. And we're gonna use the point color. So because we have by default almost all default preset materials, they all have this use point color checked anyway. So if we do that. Oh, I mean, as long as use point color is checked, which is this point color, if you go back into our object node, and then here say, let's use the material that we just created, which is coated metal, put that on there. So now we have coated metal. You won't see it in here, but if we go into, let's just create a render Mantra PBR, okay? And in Mantra PBR, let's just set some things by default. Let's see. What we're gonna do is, well, first of all, I'm just gonna change this to PNGs. EXRs are awesome, but yeah, I just want to keep my file sizes down. I'm not gonna do anything really complex, and it's not gonna be a really complex file that I'm gonna be rendering to. We'll keep it at 3. We can up this up later when we want a better quality render, but I'm gonna bring the samples down to something like 4 or something. And let's see here. Let's put our limits, and we don't need too many limits, so it's 3, 3, and 2, just because that's what I usually use as default. I just realized we don't have any lights, so let's just use an environment light. Okay. And with the environment light, I'm just going to grab a random HDR. So I'm going to go into my HDR library here. And we got HDR images. Dotted with, there's a lot of different things. Let's take a look at what they actually is. So show images, so you can actually see things. So these are all my HDRs that I have by default. Some of them are free, some of them are paid for. So let's just use something that looks visually interesting. Let's see. What do we have in here? Let's just go with this. Let's go with this one. Accept. So now this guy is all around us, and we don't really need to see him, but render, that's fine. Okay, so now if you go to having all that set up, we have a material in here, we have a light, which is going to be an HDRI that's lighting it, and we had set up our render node, so our ROP here in outputs. If we go to render view, and we just hit render, you can see what that looks like. It's going to take a little while, I think. It's generating the scene. And so, hopefully, this is correct. Wait, where am I? There we go. Sorry, that was just extremely huge. There we go. So now we sort of have that same look. Cool. Let's take a look at it in actual render mode. So yeah, we sort of get this jaggedy anti-alias look because of the coarseness of. Oh, that was kind of weird. It's just. Hello. There we go. The coarseness of this from the resolution. So actually, if we maybe if we blur it out a little bit, you can actually get a little bit of a better look. So let's just turn this off. So instead of this here, let's go back into our geometry and go into here, and we can either. So what you could do, which to give it more resolution, is you could just up the VDB from polygons voxel size lower, so we get a higher resolution mesh. But like I said, that will kind of sort of start making things really, really slow and laggy. But if we put this to like 0.5 or something, you're gonna see that we're gonna get a lot. So you see how long it's taking to calculate all this stuff though? Or we're gonna get sort of a little bit finer mesh, right? So you see how it's a little bit of finer mesh, but it did take a while to calculate. Especially since we're actually we still if you remember, we animated the diameter of the sphere, so it's actually going to start eating into this as the timeline goes down. So you see how it's eating into it. So because of that, like the higher the VDB from polygons we make, the longer that calculation is going to take. Which, I mean, you know, honestly, at render time, if it's a little bit slower, it's still going to be okay. But also what we could do is, instead of upping the res, we could just blur it out a little bit. And so I think we can just get an attribute blur. I believe that's the first one here. And we can just blur out, see if that works. So we're gonna blur, not P, we're gonna blur CD. So it kind of blurs it a little bit, and so you sort of fake it a little bit. If that's the case, you might want to spread these apart a little bit further, I think, so they're a little bit more, you know, definite before they get blurred out. Something like, maybe something like this. This one actually, the first one actually can get pulled pretty close, because you want this just to be just at the edge, I guess. And then the rest of these guys can be sort of like that. And so if that's the case, and you do that, just with that blur, hopefully we get a little bit of better look. come on, generating the scene and start the render. And so here we go, here we go. So yeah, you get a little bit of a more blurred look on that, but you know, you don't start to see the weird pixelization. So that's how we'll do that. And so if it animates, that the thing sort of eats into it and starts revealing these things. So if I go like back out here, it might take a little while to generate again. But anyway, so yeah, that's how we do that. All right. Let me just save this out. So let me stop this and save this out as, let's see. Moving forward, Quantum Negative or anybody else, we have a few more viewers, I guess, now. If you're watching, say something in the chat. If you have any questions or if you want me to go over something, like I said, I've said this 1,000 times before, but I'm not really an advanced user of Houdini, so I can try to answer any questions that you have or try to demonstrate or teach something that you would like to know more about, but I'm pretty sure there would probably be better ways of doing it, but I can try to show you my approach to it, and that's all I can really share. So let's just save this out real quick. Let's just call this, just make a new folder, just call this 011. And what was the original target thing that we were looking at? This was called, this was Tempson Van Essen. Awesome name. We just called it erosion, so let's just call it that. Oops. Let's just call it the same thing, erosion. Okay. Do that. Accept, and we'll call it that. If you want the, oh yeah, you're following along at the same time. Yeah, I guess because I'm so slow, or like so slow and doing this in real time. Yes, you can totally follow along with it. Hopefully, and you know, do the same things. So cool, awesome. So yeah, Tempson Van Essen's erosion. So. And then as usual, if you guys are watching, if anybody else is watching, and if you're taking a look, if you take a look at on Instagram at grants, that's me. And so in 2017, for every day in 2017, I made a different render with Houdini. So if you find something in here that you really want to know how it was done or have it taken apart, or a lot of times I was actually just following a tutorial and doing the same thing. And so if you want to see how that's done, or I can point you to the tutorial that I used, then I can do that. So, you know, and a lot of them are animations, so just, you know, let me know. This one's actually going to be used on something. I just got a request for this one to be used on a feature film, the opening credits for a feature film. It's actually pretty cool. Anyway, so yeah. But if there are no other questions, we could try to do something else really quickly. Something simple, maybe a little more simpler, maybe. Well, that wasn't super complex. So let's see. Let's just make a new file here. And okay, so the next thing, if there are no other questions, which it doesn't look like there is, I'm just going to go over something really quick. Hopefully it's really quick. You know me, I tend to rant. That's why I'm called G-Rant. But so I might drag it out a little bit longer. But it won't necessarily make something super cool to build. But I just want to go over a quick quick little explanation on what SOP solvers are. So hopefully it will help you understand that. But first, let me just wow, my computer is running insanely slow, by the way, guys. And let me just grab Sorry, I just need to. Okay, so let's get into this. So the next thing, so Quantum Negative is asking me, did I get anything from the screens I sent you? Are you referring to the Blender tissue code? Because I still do want to do that one, but it's a little bit more complex, and I think it would take a little bit more time. So maybe I'm just gonna push that off to next time. Plus, I still haven't. What's up, TMD? But I still haven't. The curl ball thing. The curl ball thing. I don't remember. I look back at my notes. Probably. Like I said, I think I mentioned this last week. I'm not sure if yeah, I don't think you tuned in last week, but recently I've been really busy every night because I'm kind of like going through this whole weird Vex. Vex is the coding language for Houdini, so I'm going over this weird like Vex tutorial beta testing lesson plan type thing with Matt Estella, and so it's actually really cool, and I really enjoy doing it. I can't believe Matt. I was able to. I'm actually having contact with Matt Estella, the Matt Estella of CG Wiki, and he's like writing little lessons to beta test it. To try to develop a course or a quick course on learning Vex for people who are really crappy at Vex, which is me. I'm really shitty at Vex, so that's been taking a lot of my time. But the curl ball thing from Matt, I'm not sure what that is. We'll get back to it. For now, the last thing I'm gonna do today is I'm just gonna go over the SOP solver really quickly, and the SOP solver. Sorry if I'm veering off topic. I can't remember exactly what you're talking about with that curl ball thing. But what I kind of wanted to go over today, or right now, this little last thing is the SOP solver. So hopefully this is a way to illustrate it. It's not the best. There's way more complex and way more better ways of using the SOP solver, but this is one that kind of clicked in my head, and I use it for a lot of my renders last year. So as usual, let's put a geometry SOP down, okay? And we're gonna delete this out. And we're just gonna grab a sphere, okay? And turn that into a polygon. But we're going to just up that a little bit, get a little bit more resolution on there. Actually, let's bring this scale down a little bit too. 0.3, 0.4, maybe. And we're gonna drive it with a mountain SOP like we were doing earlier. So we just give it a little bit of noise, just a little bit. Okay, so now we get a little bit of noise, but this time around I'm gonna make it, I'm gonna change up the type of noise. That's a little weird looking, but let's see what happens if we, ooh, that's a little bit weird. So that's not what I'm looking for. Perlin, that might be the one we're looking for. So I'm gonna do this. Let's take a look at some of the other ones. Perlin, nah, probably not. Simplex might be cool. Sparse convolution. Flow, periodic flow. Alligator. Let's just jump to alligator and do something like. What am I looking for? A better version of what I'm looking for. That could work. You know what? Let's just stick with Perlin. Okay. So now, so we got noise on this Perlin. But what I'm going to do is, actually, I sort of jumped ahead of myself. We're going to put a transform on here. Okay? So now with this transform, we can pick this correctly. Yeah. So with this transform, that's weird. There we go. You know, you can move around the sphere, obviously. But what I'm going to do is I'm going to use some math to move it around. So it'll just move around automatically. So if you remember from math class, if you do sine, then I'm going to use the sine of the frame number. I'm going to times this by 1 and times the whole thing by 1. Okay? So we're going to do that. So now if we take a look at it, it's just going to be moving back and forth from 1 to -1. And if I times this by more than that, it's moving a little bit faster. So I'm going to move it a little bit faster than that, maybe 4. Right? Now if I times this, it'll go from instead of 1 to -1, it'll go 2 to -2. So that's a little bit more along the thing I wanted to go, the distance I want to go, but let's slow it down by a little bit. Let's just do that. Okay. Now, if we grab this, and I promise I won't get any more mathy than this, guys, but if you just put a cosine of this, what happens is, on a y, so if we did, okay, so if we did a sine, let me show you this. If we did a sine of the exact same thing on y, it's just going to do this. And basically, it's going to go vertically. But if we instead do cosine, which is sort of like the invert of it, it will actually start going in a circle. Isn't that cool? So yeah. So we have that going in a circle. Now, if on top of that we do this, originals, paste it again, we sort of get this. But let's also, what happens if we add at f? So now at f, actually, is this even doing anything? At f times 20. So is that even doing anything? No, that's actually not what I wanted us to do. Let's just offset it a little bit. So it can still be 2, we were doing earlier, but let's just offset it by, instead, make this 5. So there we go. So now it's kind of sporadically, or kind of moving a little bit all over the place, right? On top of that, if we do the mountain, so you see how it's sort of getting this weird kind of look. And it's really as it's moving, it kind of looks like it's sort of trying to crawl, which is actually pretty cool. And the reason you can actually change it to be a little less violent with the element size. So if the element size just gets a little bit bigger, now it's sort of calming down a little bit, I think. So because if we turn this up really high, you see how it's not really changing too much, because the noise field that it's running through is a little bit bigger. So now we're bringing it a little bit smaller, so as it moves through the noise field, there's a lot more of a variation. And so on top of that, what I want to do is just make the height of it a little bit bigger. Okay, so now we've got this weirdness going on here. Okay, now I think earlier, well, how many times have I already done this? But you know, the thing that I love to do is turn things into VDBs. So I'm gonna do VDB from polygons. So I'm gonna take that and I'm gonna turn them into VDBs. So now we're basically basically turned it into a volume, right? And now what we're gonna do is we're gonna put a solver SOP. I'm going to feed this into here. Okay, and so that disappears, right? Let's just stop this for now. And so let me just explain really quickly what a solver SOP, or what the solver SOP is. So we haven't gone into dynamics in Houdini, but dynamics, basically, the basic concept of a dynamics is base the next frame on something that happened in the previous frame. And when it comes down to, all dynamics kind of works like that. It does a calculation on something based on what the result was of the previous frame. I'm probably not explaining that well, but that's basically what dynamics are. when it comes down to it at its fundamental level. So whether it's flip fluids or rigid body dynamics or soft body dynamics or whatever, there's a bunch of different calculations in pyro, all that stuff. It's a bunch of different calculations, but at its core, all it's doing is adding more calculations onto something that it took from its previous frame. So what the solver SOP is basically that, but on the SOP level, and is a very, very basic version of that kind of system. So if you dive into this solver SOP, if you take a look, usually we go one in, one down, one down. Well, the solver SOP actually just does a bunch of like fake outs, and it actually is a dynamic system, but it's showing it to you this way. So anyways, so like I said, it takes a previous frame, and it takes the input here. So input 1, 2, 3, and 4 correspond to input 1, 2, 3, and 4 here. So what we're going to do is, hopefully I get this right, we're going to keep merging the previous frame's volume onto the current frame. But we're also going to have it deteriorate every frame. So it's going to start to kind of eat away at itself, but also pump in the new geometry. So let's see. So that would be a V to B. Hopefully I do this right. V to B combine. And so we're going to union it. Okay? So basically it's going to be taking whatever comes in, so the volume that comes in, so the SDF that comes in from the input 1, and it's going to combine it, it's going to union it with whatever came in the previous frame. So if we do that and we step out of here, if you take a look at it now, you see how it's doing this, and it's continuously building on itself. And it'll just keep adding to it, and it'll just keep adding and adding and adding, until it becomes just basically what it's going to do is it's going to keep adding until it goes around the gamut of every single point in a sphere around it, because it's being transformed by these guys, which they're going to go in a perfect circle until it makes the entire sphere. It's going to be a noisy sphere, but it's doing that. Hopefully that makes sense. Okay, and you see how we've built this on this way. So now, because we went through it once, it actually cached our dynamic simulation. But on top of that, what I'm going to do is I am going to do a reshape SDF. Now what a reshape SDF does is it can either dilate or erode. So dilate meaning it'll expand the SDF volume bigger than it is, or if it erodes, it's going to make it shrink from where it is. And so I'm going to actually make it shrink. Okay, so you see how it kind of shrunk. You also see how our once, what was it, green? Whatever, cached dynamic keys now turn orange, is because Houdini realizes, oh, something changed. So now our previous cached dynamics does not work because of the change. So I'm gonna have to recache these. So, I'm gonna have to play it again from start in order to get an accurate representation of what's going on. But anyway, suffice it to say that this V2B reshape is now eating into it and making it smaller. So what it's gonna do now is this result is now gonna be coming in on this frame and combining with the full V2B and the next frame. And the same thing will happen. It'll be combined, but then it'll also be eaten away at, and then that will be fed into the previous frame, and then the healthy new volume will get merged, and then over and over and over again. All right. Now you can actually adjust how much it eats into it with this. By default, it's 1, and I'm pretty sure that's probably going to be too aggressive, but we'll just see what happens. So if I dive back, or if we step back out, and I reset myself to here, and I take a look, you see how it's not really doing anything? Yeah, it's sort of not. Doesn't look like it's going anywhere. It's because it's eating away into it too fast. So let's just dial this down a little bit. So let's just eat away into it by like 0.1. Let's see if that does anything. So now, if you take a look at it, you see how it's sort of deteriorating over time, which is pretty cool. This first one here, let's figure out why it's the first one. And the reason being is because on this, I think the reason is because on the first frame, we don't have a previous frame to pull from. So in order to do that, we just need to put a switch. And what a switch does is it will switch between the whatever inputs we are. So if you take a look at the switch, you see how this is the solid line because it's taking input 0, which is the first input. If you take input 1, it's going to be this line. So it's going to take whatever input 1 is. So what we want to do is actually just put in a quick equation in here that says $f equals 1. That does not work correctly. Oh, it's supposed to be because it's equals 1? Should be. Right. Okay. And so what that does is... Wait, is that correct? Yes. So on frame 1 and frame 1 only, it will port to the first input because on frame 1 we don't have a previous frame. But then after that, if we take a look and we step 1 later, you see how it turned into 0? It's because now this is no longer true, and if it's no longer true, it's going to be giving back a 0. So that's basically what that is. So hopefully that's correct now. So now if I step out, that first frame is not going to get frozen like it was before. Actually, you know what? It is frozen. Why is it frozen? I think it's frozen because... Is our viewport just messed up? Let me see. Let me just make a new viewport. So we make a new viewport. We take a look at this. Hopefully, if I press play, yeah, you see, it's just the viewport was screwing up. Guys, that happens. It's really weird with Houdini sometimes. If it's not behaving correctly, all you got to do is open up a new one, and then this one is still going to be behaving wrong, but you can actually just close this guy out and then just use this new one that you created. Sorry, I don't know. I don't know any other workaround to doing that. It should basically just resets your viewport. Sometimes it just gets glitchy and like things hang. Like even if you ghost or hide other objects, sometimes the ghost still stays. It's because you just need to refresh your viewport. So so basically, it sort of leaves a little bit of a ghost behind it like that. I would like this chain to still continue, and I think that's because our mountain sop. So at this level, it's turning too small. So if we up the scale of this, it actually might look cooler, I think, because at this point, at this level, you see how it's not turning really too small, hopefully? Let's actually make it even bigger. I hope this works. So at this level, if we put the solver sop on here, well, that's actually a little bit too big now. But you see how it turns into a weird creature looking thing with the tail kind of, we're still getting a little bit of this. And I think that might, okay, first of all, it might be helped if we don't make it as big, but at the same time, let's make this, this reshape just a little bit more aggressive so it eats away at it a little bit faster. So how's that? So now, yeah, we got a little bit of this going on here. So you get this weird thing going. And then from there, like I said, all you need to do is do a convert the VDBs back into polygons. So convert VDB back into polygons. And so now you just get this weird sort of creature thing that's sort of like moving around. And I hope that makes sense. But that is basically sort of using the solver sop for what it's intended to do. So basically, bringing in your input, whatever input that would be. So you can actually combine stuff, and you can actually make it this really, really complex. But then it's also taking into account the previous frame somehow. So if you just remember that logic and remember that whatever your out is here actually ports back into here and then gets combined in the whole chain of things. And that's how that works. And so I'm gonna leave it at that. But this technique I'm doing with the whole, and this is just to show you what solver sops do and stuff, but this whole V2B with the solver combination is basically how I did, let's see, stuff like I think this one uses it. Actually, this one does it without the you just saw exactly what it does. It does it without the reshape. But if you take a look at ones like, I use it all the time, guys. This one, same thing, right? And it just has a sphere at the beginning. Or I mean, I use it a lot. So you know, I was using it a lot because I was just trying to see what kind of different results I was getting. And so like this guy, that's what that is, you know? So yeah, that's it. But anyway, so I hope that was kind of, you know, interesting. So I think that's it for today. I kind of went a little bit over time. Actually, no, it's right around the time that I usually try to aim for. I'll try to. Well, actually, I just got an email from Quantum Negative. Okay, this is actually okay. So here is, yeesh. TMD Christian. I don't know how to pronounce that, so hopefully. I guess you're getting out of here. Cheers or something. Thanks for stopping by, dude. I'll see you in the Brograph Slacks. Quantum Negative. Okay, yeah. So hopefully that was good. Oh, and yeah. So TMD, it definitely cleared up a few things for me. Yeah. Okay. So hopefully, yeah. So that's how you use like the solver SOP. And like dynamics is all built on that. It gets a little bit more complicated than that, but you know, that's how it goes. Let's see. So I'm taking a look at Quantum Negative's email that he just sent, which looks really, really complex. And maybe we'll get around to this next time. I'm gonna take a look at it more, but it's actually, yeah, let me show this. And I was wondering if you could recreate this. So yeah, I would have to. I'll take it apart and I'll take a look at it, and try to see what I can make of it. And then maybe next week we'll try to do that. You always give me really, really interesting stuff to try to like take apart. So I'm kind of curious about that. The Blender tissue code is still something that like I kind of is sort of getting it, but I want to refine it to get it even better and get it. My goal is to make it animatable. And I don't know if I can do that just yet, but it's sort of getting there. So anyways, yeah, so I'll take a look at this one too, and then hopefully next week we can sort of tackle it. I hope. I don't know. Just from screenshots is kind of difficult. If you have the scene file as well, but then again, if you have the scene file, you can just take it apart, I guess. But if you have the scene file, you can find the scene file. I would totally. But I might be able to just guess and mess around. I'll mess around with it, and we'll see for next week. All right. And that's it for this stream. Thanks for tuning in, everybody. Yeah. Take it easy. And so where is the off button? This. Go. All right, take it easy, guys. Bye.